Virtual work method due to external loads. So virtual work is the total work done by applied forces and the inertial forces of mechanical system as it moves through a set of virtual displacement. When considering forces applied to a body in static equilibrium, the principle of least action requires the virtual work of these forces to be zero. The principle of virtual work was developed by John Bernoulli in 1770 and sometimes referred to as a unit load method. From this equation number 1, we just formulated equation number 2 which we distinguished virtual loadings and real displacement. From this, we have known the work of external is equal to work of internal loads. So the following mathematical expression in simple stands for P is equal 1 is equal to external virtual unit load acting in the direction of changes. U is equal to internal virtual load acting on element in the direction of the DL. Change is equal to external displacement caused by the real loads. DL is equal to internal deformation of the element caused by the real loads. In the same idea, 1 multiplied with theta is equal to summation of u theta multiplied to dl for equation number 3, where m is equal to 1 is equal to external virtual unit coupled moment acting in the direction of theta. U theta is equal to internal virtual load acting on the element in the direction of dl. Theta is equal to external rotational displacement over slope and radiance caused by the real loads. dl is equal to internal deformation of the element caused by the real loads. Determination of displacement due to external loading. From strength of materials, truss element deformation is dl is equal to summation of nl is over 2kb. Thus, the virtual work equation for a truss is 1 is multiplied to change is equal to summation of nl is over ae for equation number 4, where 1 is equal to external virtual unit loads acting on the truss joints in a stated direction of change. N is equal to internal virtual normal force in a truss member caused by external virtual unit load. And change is equal to internal joint displacement caused by the real loads on the truss. And N is equal to internal normal force in a truss member caused by the real loads. L is the length of a member, A is a cross-sectional area, and E is a modulus of elasticity of a member. Virtual work applied to truss. From figure 1, it is an example of real system, and the figure 2 and 3 are examples of virtual system. From these figures, we derive the equation 1 is equal to change V is equal to summation of SVL, and 1 change H is equal to summation of SVL over AE, where S is the external normal force in a truss member caused by real loads, and U stands for internal virtual normal force in a truss member caused by external virtual load placed at the joint. Whole deflection is required. L is the length of a member, A is a cross-sectional area of a member, A is a modulus of elasticity of a member, and change in V is a vertical displacement or deflection caused by the real loads, and change of height is a horizontal displacement of deflection caused by the real loads of the truss. For example number 1, from the truss shown in the figure, it is subjected to what horizontal force of 10 kN at joint B. Assume that AE is constant with E is equal to 3000 MPa. A is 500 mm squared using virtual work method. So first, we need to compute for the vertical reaction of C. Secondly, compute the horizontal component of deflection of joint B. And lastly, compute the vertical component of the deflection at joint B. Firstly, we need to put all the data given from the problem, like the AB and the BC. Also, I put the data theta on each angles of the given figure and added the 5 kN written on the problem. Also, I also wrote the 5 meters on the both sides. So now, vertical reaction at C. So first is summation of M change is equal to 0. Then 6 RCB is equal to 10 multiplied to 4. RCB is equal to 6.67 kilonewton. Writing that on the given figure, so RAB is equal to 6.67 kilonewton and RCB is equal to 6.67 kilonewton. For horizontal component of the deflection at B, so summation of f of x is equal to 0. BC multiplied to 4 over 5 is equal to 6.67. So BC is equal to 8.47 kilonewton for the compression. Next is f of x is equal to 0. AB multiplied to 4 over 5 is equal to 6.67. So AB is equal to 8.34 kilonewton. That is the tension. Now, I'm gonna draw the free body diagram of these angles. So BC, theta, and C. So 5 kilonewton is equal to 6.67 kilonewton. That's for the BC. And for the AB, so this is the free body diagram. Going on, now let's distinguish the place of horizontal unit at load B. So summation of M of A is equal to 0. GR1 is equal to 1 multiplied to 4. So R1 is equal to 0.667 kilonewton. BC is multiplied to 4 over 5 is equal to 6.67. So BC is equal to 0.834 for the compressions. Next is AB is multiplied to 4 over 5 is equal to 6.67. So AB is equal to 0.834 and that's for the tension. Next is, let's draw again the free body diagram of this horizontal unit. So based from the table given here, so we will now distinguish the virtual work method. So first is we're gonna use the given formula, which is change in pH is equal to summation of its UL over AD, and then change those mathematical expressions into the given units. So it was written in here 69.56 multiplied to 1000 over 500 multiplied to 3000. That will be 0.0464 inches, or change and pH is equal to 4.64 millimeters. Next is we're gonna know the vertical component of deflection at B. Place a vertical load unit at B. BC is equal to 4 over 5 is equal to 0.5. So BC is equal to 0.25 kilonewton and AB is equal to 0.625 kilonewton. BC and AB are both compression. Now I'm going to draw the free body diagram of this vertical unit. Next, from the given table here, we will now also distinguish the vertical work method for this vertical unit placed at B. So again, we're going to use the formula given. Change in ABB is equal to summation of E as UL over AE. So ABB is equal to 0 over AE, or ABB is equal to 0. So here's another example for you to try. So reading from this problem, from the given trial shown in the figure, it is subjected to horizontal load of 20 kilonewton at B and vertical load of 40 kilonewton at B. Assume AA is equal to E is equal to 100,000. So again, just compute the reaction at C, compute the horizontal component of deflection at B, and compute the vertical component deflection at B. Through this, you will be able to get the first is the compression, which is AB is equal to 5.66 kilonewton and AC is 2.4 kilonewton for tension, and for summation of EMA is equal to 0. For the R1, it is equal to 0.6 kilonewton, and R2 is 0.6 kilonewton also. And then for the summation using the given table, so the change in ABH will be 0.007 meters or 0.7 millimeters to the right.